Now that we've learned our three algebraic methods, we want to discuss how we can choose between those methods. Like I mentioned, sometimes one option will work better than the others, or in the case of the square root method, some options may just not work. So, something I want you to consider, let's look at these three functions here, which are graphed for us already. In red we have x squared plus 1, in blue we've got x squared, and in green we've got x squared minus 1. And the question would be, how many roots does each of these parabolas have? Or in other words, if I set them equal to 0, how many solutions would I expect? Okay, so for the red one, it never hits the x-axis, so there's no roots. The blue one hits it once, so there's one root. And the green one hits it twice, so there's two roots. So those are pretty much our three possibilities. You're either going to have 0 solutions for a quadratic equation, 1, or 2. And a tool that we can use to help us determine how many solutions we're going to have is called the discriminant of that quadratic function. So if you've got a function that looks like ax squared plus bx plus c equals 0, right, kind of that old form for a quadratic, this should look familiar. This is the stuff that appears underneath the square root in the quadratic formula. Right there, b squared minus 4ac. And it turns out, if that number ended up being positive, then when we did this calculation for quadratic formula, we would get two different answers. If this expression that goes under the square root in quadratic formula was 0, then we'd be adding and subtracting 0, and essentially we'd only have one answer. And if this is negative, then the stuff under the square root is negative, so you have the square root of a negative number. That means you'll have two solutions, like this guy in red, but they're actually both going to be imaginary solutions. That's why you don't actually see any roots there. So we've kind of summarized that comparison here. If the discriminant is positive, then you're going to have two real solutions, and you can use whatever method you want. If the discriminant is 0, then you're going to have one real solution, and you could still use whatever method you want. The real use for using this is if the discriminant is negative, then you know not only that there's going to be two non-real solutions, in other words, stuff involving I, you also know that you really should be using the quadratic formula to solve that equation. Okay, so one way of approaching this is anytime you have a quadratic equation, you could just use the quadratic formula every time. But if you want to do a little more sleuthing and figure out what exactly is going to happen along the way, or am I forced to use the quadratic formula, if the discriminant is negative, you must use the quadratic formula. That's the only method that's going to get you to your answers. So let's try out using the discriminant here and see what we can do with that. We have x squared equals negative 2x minus 3. The very first thing I want to do is get it in the right form. In other words, have it equal to 0. Great. So a is 1, b is 2, and c is 3. And in keeping with what we just learned, I want to immediately calculate that discriminant d. So b squared minus 4ac. In this case, that's going to be 2 squared minus 4 times 1 times 3. 4 minus 12, that comes out to negative 8. So in other words, our discriminant is less than 0. If we look at our table here, that tells me I'm going to have two non-real solutions, and I better use the quadratic formula to solve this equation. So even if I had been so inclined to maybe try factoring or the square root method, I really need to use the quadratic formula here. That's the only way it's going to work out. So let's go ahead and use the quadratic formula then. X equals negative b plus or minus the square root of b squared minus 4ac, and divide the whole thing by 2a. And let's clean that up a little bit. Okay, so let's go ahead and clean this up some more. Anytime we have the square root of a negative number, we need to remember not only to pull out perfect squares, but also to pull out negative 1. So I've got the square root of negative 1 times the square root of 4, and the thing that's left over is 2. So let's clean this up even more. That's I and 2. So everything here needs to get divided by 2. Let's go ahead and break this apart into separate fractions just to avoid mistakes. And if I simplify those guys, it's negative 1 plus or minus I times the square root of 2. So yes, I got two solutions, and they're both non-real, meaning they both involve I. So if I had tried to graph this original problem to solve it using the intersection method or maybe the x-intercept method, I wouldn't have seen any points that indicate solutions. But using what we know about the quadratic formula and the discriminant, we know there's actually going to be two solutions, and they're not going to be real numbers. So that's what we were able to find here.